Can you see the screen?
Yes.
Okay,
So you can
slideshow here.
Yep. Great. Yes. So basically, what this event is about. So I mean, the plan is at least to have it in 2 different sessions. So basically, we'll try to cover as much as possible from the Firebase offering, and because they are, I mean, they have quite a lot to offer, a lot of different products. So we'll try to give you a theoretical background, or maybe more of an introduction to the whole suite. So this event will focus more on the build aspects, and after the theoretical parts, we'll also try to give you a demo and also some interactive parts that you can do on your own. But yes, you can go to the next slide. So the agenda for today will first of all, of course, be an introduction to me and Sijohn, so you get to know us a little bit better. Then we'll do a short introduction of Devoteam, so basically the company where we come from. Then we'll do the theoretical parts, which is more about the actual products, the offerings in the build topic, or the build top subject. Then we'll actually do questions before we do the interactive session. So we'll do some questions, then we'll do a demo, and then the absolute last part is for you to actually do the practical parts on your own. So we'll stay in the meeting for a bit, so you can do the practical parts as well if you want to, and we can be here for any questions that come up. But you will also have access to the instructions, etc. So you can do it tomorrow if you'd like. So no hurry on that part. But yes, go to the next slide. So you can actually skip this right away. Yes, so just a short introduction. First of all, my name is Mikael Fredriksson, as mentioned. I'm an agile lead and cloud developer working for Devoteam, specifically Devoteam G Cloud. So I'm managing a lot of agile teams and doing some development on the side, mainly focusing on backend development, barely doing any frontend at all. But everything is related to GCP in a sense. And yeah, I think that's about it. I worked for Devoteam for about 2 years now, since I've graduated from school. Yeah, that's about it. Sijohn?
Yeah, thanks, Mikael, for the introduction. My name is Sijohn Mathew, and I'm a senior cloud architect with Devoteam, and I'm also working mostly on the Google pillar. I mean, the GCP cloud, primarily focusing on the application development side of things. When it comes to the application development, my background is from a programming or a application developer background, working in Java, JavaScript, TypeScript, etc. And I am working in Devoteam for the last 1 year, and then that's it. That's pretty much from my side. Over to you, Mikael.
Yep. Next slide. Yes. So a short introduction to Devoteam itself. So yeah, basically we are quite a big company, actually, headquartered in France. But you can see it as, I mean, we have multiple smaller entities inside this big Devoteam group that are located in different places. So both me and Sijohn are based in Stockholm, in Sweden, and we are in a pillar called Devoteam G Cloud. So we are focusing purely on Google Cloud itself. We have other pillars inside this group that are focusing on, for example, the other public clouds we have for ServiceNow and Salesforce, I think it is. So I mean, we have different pillars that are focusing on different things, and yeah, we are in the G Cloud pillar. So this slide specifically is covering more of the G Cloud pillar. So we have more than 300, almost 400 Google experts in Devoteam G Cloud, and as you can see, we have more than 2,000 customers. and quite a big revenue actually. And so you can also see that we have been the partner reseller of the year. I'm not sure if we actually have one later than this, but so we're working very closely to Google. Yeah, that's about it, I think. Can probably go to the next slide. So this is a short introduction of the actual Firebase products that we'll be talking about today. So there are a few different topics. So for example, the hosting capabilities and data management, but in there you also have a bunch of different products. So we'll go from top to bottom more or less and go through all these, give you a short introduction and maybe some things to think about. And then we'll go into questions where you can ask any questions you may have. Of course, if you have any questions already now, feel free to stop me or Sijohn in that sense and ask those questions. I think that's easier so we don't forget about them. But yeah, after the theoretical parts, we'll do the demo as well. So Sijohn, over to you.
Thanks, Mikael. So yeah, so as Mikael mentioned about the Firebase suite of products, I'll be covering the first 4 sections, like the authentication, and then followed by hosting, the Firebase hosting, then the cloud function, and then the Firestore, one of the databases from the Firebase suite of products. And the rest of the section will be covered by Mikael. So authentication. So Firebase authentication, as the name suggests, it is the same thing, like the identity provider from the Firebase suite of products. So before getting into the Firebase authentication, just want to bring up the main authentication. When we talk about authentication, we talk about the security functions. Whenever we develop an application, there is something called a AAA model in the security function. So what is actually Firebase authentication trying to solve in that AAA model? In the AAA model, the first A is authentication, second A is authorization. So authentication is nothing but who am I? Authorization is like what am I supposed to do? And accountability, the third A, which is what did I do? Basically the audit trail part. So when it comes to the Firebase authentication is trying to solve the first A, which is the authentication. And to an extent, it will help you to solve authorization part using a feature called custom claims. But it is a very, I would say it's a very early or like it's not a very matured way of solving things for an enterprise level. So normally, only the basic apps will use that custom claims for the authorization part. So we are trying to solve here only the authentication part, which is basically the identity, who am I? So when it comes to the Firebase authentication, the good part with the Firebase authentication is that it gives you the SDKs and ready-made UI libraries to authenticate. So basically, when you say the ready-made UI libraries, like you can plug and play those libraries into your JavaScript framework based applications, like built on React or Angular or Flutter or whatnot. And when it comes to the auth providers, Firebase support almost all the major auth providers, including the native providers like the email password based authentication. Like let's say you want to provide a simple email password based authentication, it's also supported. So you don't have to build any kind of engine for your app. It's like you enable the Firebase authentication and then bringing that SDK into your app. It's that simple. And then phone-based authentication, if you want to authenticate based on your phone number, and then you get an SMS back. So those kind of things. Additional providers are like, it supports the OAuth 2.0 and the OpenID Connect protocol. So you can bring in all these kind of, these are called the federated identity providers, basically the Google, Facebook, Twitter login, everything. So that's how that elaborate is the Firebase authentication engine, and it's so easy to plug and play into your app. So you don't need to bother much about how the authentication works under the hood. But having said that, being a developer, you will be always curious like how the authentication works on a very high level. So basically, let's say you build an app. So you get the credentials from the user using a login page. It can be either an email password based or like kind of a sign in using Google. So then you will get that token from Google, the OAuth token from the federated identity provider like Google. And then these credentials are passed to the Firebase Authentication SDK. And then the backend will verify. So that part is completely handled by the authentication engine. And then the auth engine from the Firebase will respond you back with a JSON web token. So that web token can be used in the app itself to extract other details. Like let's say in your Google, the user has signed in using Google, then you have a profile pic in your Google, then you can extract that part from the token what you got from Google actually. So basically you can extract all kind of details from that token what you get back from the auth engine. So moving forward, this is how the, on a very high level, the auth works, authentication engine. And if you want to extend the authentication engine, like there are various few use cases actually. This is not limited to this set of use cases. These are two examples basically. There is a concept called cloud functions, which we will cover in the next slides. So the cloud function is the serverless offering from Google or Firebase. So if you want to extend the authentication engine, like let's say a user has signed up in your app and you want to send a welcome mail. So how do you do that? So you can get triggers from the auth engine, and these triggers can be captured in cloud functions. So cloud functions can listen to on user create or on user delete, these kind of events. So when you get these events, you can write a simple cloud function. When you say function, you can write it in TypeScript, JavaScript, Node.js, Python, Java, etc. I mean, it supports multiple languages. So you can write it in your favorite language and then send the mail, a welcome mail with, and if you look at this code snippet here, this user object will carry all kind of details like the email, first name, last name, all kind of details what a user has done during the sign up process when you capture. So similarly, the other event is like on delete. So it's like similar use cases. So this way you can think about various possibilities for expanding the application, the authentication part itself. And it is, I mean, from a developer's perspective, if you use this, you don't need to manage or bother anything about the infra part. You just bother about writing the piece of code, what is the functionality it needs. And this question is basically the Firebase Authentication SDK supports multi-delete. When you say multi-delete, batch delete. So something like a function like delete users and pass all the user IDs. But unfortunately, this is not captured in the by the on delete event. So beware of that. If that is the case, then you will have to loop through the users and then then only delete one by one if you have any kind of function getting triggered by a delete event. If there is no functions need to be triggered for this delete, you don't need to send a by mail or something like that. Then you don't need to bother about it. It's just a caution. So that is pretty much about authentication part. If you, the next step is basically to go into the Firebase console, and then I can show you the authentication part, which we will do it in the demo time. Otherwise, the extension of Firebase authentication, we can do a lot of things using this cloud functions concept. Club with that. So I'm moving forward to the next one, which is basically the hosting capabilities of Firebase. So how to run your solution using Firebase. So Firebase again offer similar to authentication. It offers the hosting part, which is basically a fast and secure web hosting. So when it comes to the Firebase hosting, it provides a production grade web content hosting for developers. So for developer, they don't need to bother anything about where to host, how to cache. Let's say you are building a global web app where users are accessing across the world. Then from a traditional perspective of hosting, you need to bother about how my content will be served across all these CDNs. Like the CDN means like the content delivery network, how it is cached, etc. So when you use a hosting provider like Firebase, you don't need to bother anything about those things because Firebase internally handles everything. You don't even need to provide any kind of extra configurations for those, because Firebase is purpose built for serving the content across the globe. And you can leverage the Google's Edge CDN cache, and those CDN caches are running on SSDs. Like SSDs are the most powerful and the fastest disk which can serve all these contents. And if you are deploying a simple web app, a kind of a landing page, or a complex like the new gen progressive web apps, everything, I mean, from a static and a dynamic content, you can host it on Firebase. So how this dynamic content is hosted is by clubbing again the functionalities from cloud functions or another serverless features like Cloud Run. I mean, I'm not going into that part to serve this dynamic content and host these microservices. So basically, Firebase hosting, when you pair with this, you can even build microservices. Not about simple websites or a landing page you're hosting. You can actually make it more powerful. Your apps can be more powerful by clubbing other features from the Firebase product suite and then deploying in the Firebase hosting. So, and
I didn't get that. Could you try?
Sorry, my watch Siri got off. Then some other key features of the Firebase hosting are like, which we have already discussed about this SSD back hosting around the globe. Okay, then the free SSL certificate for custom domains. So when you deploy an app and you can actually wire your custom domain. For example, today you have something like xyz.com or example.com. You have purchased from your domain provider, DNS provider like a GoDaddy or even from the Google DNS. Then you can link your custom domain and wire it back to your Firebase hosted application, and then Firebase will automatically provision a free SSL certificate for your app. So you don't need to bother about you bringing your own SSL certificate and then wire it and map it. And also deployments and rollbacks are like super easy with a single command. Basically, it's a Firebase space deploy command, which we will do it during our lab session, our demo session. And then there is another feature called previews and channels, which I will talk a bit about it on the next slide. So this is a very high level step about how to connect your custom domain. Let's say you have purchased the domain from GoDaddy. I mean, from a developer perspective, you don't even need to have a custom domain when you are building an app, because Firebase itself will create by default, every Firebase project will have the subdomain at no cost. So when you deploy an app, you will always get a subdomain at, for example, my project name is Sijohn Playground here, or Sijohn Devoteam. Then I will get always a free subdomain called Sijohn Devoteam.web.app, or like Sijohn Devoteam.firebaseapp.com. But if you want to link it, these are the steps. It's basically 4 steps. Just add your domain name to the Firebase console, and then Firebase will give you a key. I mean, a set of not a key, basically a key, and then the DNS details. And then you have to go and update your DNS records in the DNS provider. In our case, example, GoDaddy. Then it will sync back to the Firebase hosting, and then that's it. The SSL certificate will be provisioned, and then you are live. And the content will be over all the global CDN. So that easy it is to connect your custom domain when you're using Firebase hosting. So this is another concept which is mainly used in enterprise world, not like when you are developing your app of your own, but when it comes to the enterprise world, we will use this live and preview channels. So the concept, I mean, the preview channels are still in beta stage, but it's a wonderful feature. So the concept is like this: Firebase hosting, every project, when I say project, you can consider it as like kind of a umbrella or a container which holds all the resources. So in Google Cloud or in Firebase suite of products, when we call a project is nothing but you are building an application. And for an application, you might need a hosting service, you might need a database service, you might need like other services like cloud function, maybe you'll have to run a VM. So all these resources are brought under one umbrella, and that umbrella is called a project. So let's say we name a project like XYZ-dev project. Then once we move to production, we may have this XYZ-prod, so that we will basically segregate all the resources belonging to a development activity and then the production activity. And similarly, we can consider it as like department wise, like HR department, finance department, everyone is developing their own apps. So they can also, under one company, they can also come up with their own projects. So their resources are tightly bundled to a project. So that is what the Firebase project concept. So every project has got a default hosting URL, hosting site. So that is what this site's meaning, default hosting site. And then what happens is that a site can contain one or more channels. So by default, it will have a live channel, which will be basically our production channel. Or and then what is happening is that the content and configuration served by each channel will be packaged into a version object. So that version object is what, when you deploy the site, Firebase creates a release package, and that release package will point into that version object. So like that, we can create other preview channels. So let's say your site is running in production, and then your development is still going on in multiple developers. Then they can have their own, I mean, like when you release a new feature, you want to give it for beta, for the beta testers internally, then you can do it through the preview channels. So it will generate a temporary URL, and that too, Firebase hosting is responsible for creating those temporary URLs. So that is the whole concept of live and preview channels. You can, I mean, there is much more details into it, but in the interest of time, I'm not going into the depth of that. So that is pretty much about hosting part. So next section is cloud functions. So like I mentioned in the Firebase authentication part, if you club authentication with functions, you can build more powerful things. Similarly, even when we move to the next section about database also, we club with Firebase, cloud function. We can, I mean, it can be, I mean, so many business rules can be implemented using this. So before getting into the details of the function, the whole concept of cloud function is this, like you would have heard about the term called serverless computing, or simply serverless. This is basically an execution model provided by all the major cloud providers, like in the terms of GCP or AWS or Azure. So this cloud providers is responsible for executing a piece of code by dynamically allocating resources. So, and then this cloud providers will be charging only for the amount of resource you use to run that particular piece of code. You may not need to run that code every 24 hours, 24/7. Whenever that invocation happens, they will allocate that much of resource, and then this piece of code will be running. And this piece of code can be invoked based on various events. It can be like kind of an HTTP endpoint, like you can hit a URL and then this function can be invoked, or based on an event, like let's say a database event, a new record is created, then that function can be invoked. Or the earlier example, like authentication, a user is created, then this function can be invoked. Similarly, a lot of events can be captured and can be tunneled and passed into this function, then the function can be invoked. So that is the reason why you pass this code as a function to the cloud provider, and then the cloud provider will run it as a stateless container kind of thing. So that's the reason why sometimes this is called as a function as a service, or FaaS. So this is one of the key. So when it comes to the Google Cloud, the FaaS offering or the serverless offering, one of the serverless offering is called cloud function. But when it comes to AWS and Azure, they also have similar offerings. So just want to bring it to that term actually. So what is Google Cloud Function? So like I said earlier, it's a serverless framework to run the backend code, and it can respond to events triggered by not only by Firebase features. When I say like Firebase databases or the authentications, and even from HTTP request. So how does it work? I mean, we provide the code. We just provide the code as a function, and then it will be stored in the Google Cloud, and they have their own mechanism to store, and then run in a managed environment. So in this case, it will be like running in a stateless containers. And you don't need to manage anything, or you don't need to scale your servers or anything. I mean, based on the number of requests, the cloud provider itself will scale it up and down. If there are no requests, it will be scaled down to 0. And currently, cloud functions, they support around 7 languages like Node, Python, Go, Java, etc. So this is a simple hello world example of a cloud function. How do we write the function? So if you see here, like you just have to write functions.http, hello HTTP, and then it responds sending, okay, hello, whatever you have, the name and then the body. So it's as simple as that. You, as a developer, you just need to bother about that function, what it is supposed to do, and provide it to, there is a deploy command, and provide it to the Google Cloud or the Firebase CLI, and then that's it. It will go and package it automatically. It will be deployed, and then it will be start serving the request. One side note, today when we show the demo, we don't have anything in the cloud function. The reason being, you will be signing up in the Firebase using Firebase. There are two plans for Firebase, something called Spark plan and a Blaze plan. So Blaze plan is the paid service. Basically, you'll have to give a credit card. But in the Spark plan, it's a fully free service, and you don't need to provide any credit card information for the Spark plan. You will be using the Spark plan, and the Spark plan doesn't support cloud function, unfortunately. But rest of the things what we are discussing here, like authentication, a database, most of the things you want to try out is supported in the Spark plan. So that's a side note I just want to mention. So this is an implementation path description, which we have already, I already told during the previous slide discussion. So how do you start working on a cloud function? You will have to first set up a Firebase CLI, which is the command line interface, basically installing the tools. Then write your code, be it in TypeScript or JavaScript or whatever language of your choice. And then you test the function using the local emulator. This local emulator will be bundled in the Firebase CLI when you install the Firebase CLI tools. Then after that, you deploy and then monitor. And for monitoring the cloud functions, there are, web-based statistics and usage dashboard available from the Firebase itself. So it can be easily monitored for the number of requests it hit and etc. Those kind of things. And one another note, okay, these are some of the use cases. Maybe we can skip it because we have already discussed about the cloud function use case in one of the scenario, like in the authentication flow. So similarly, the possibilities are like, large. There is, if you think about any kind of business scenario, you can implement the business logic part in the cloud function. Not everyone has to go for cloud function, but it is possible to do it in cloud function. And now there is a new version of the cloud function releasing, which is called the generation 2. What we are discussing here is generation 1, but generation 2 is even more powerful because the current generation supports only very few type of events, like definitely HTTP events, and then the database events and the cloud storage events. But with the new release, it supports 90 plus events, because they are now supporting almost, not almost, I think all the Google Cloud products. Whenever something happens in those products, data is coming or data is created, those events can be channeled into cloud functions. So I'm skipping to this, to the next use case. This is also a simple use case, and not a simple, let's say from a mobile app, you upload an image, it will go into a Google Cloud storage, like Firebase storage. Then when a file is uploaded, the cloud function can get an event on file upload. So that event, based on that event, you can basically, let's say the use case is to generate a thumbnail for every image you upload. So you don't need to run that thumbnail generation code in your mobile. Rather, the intensive task can be run in the cloud function. So it can call the other libraries and then create the thumbnail and then write it back into a cloud storage. And basically where you have written, that storage location can be written to a database. And then finally, that thumbnail can be downloaded back to the app. So these are some of the possibilities how you can make use of the cloud function. Okay, this is the cloud function generation 2. Some of the new features, like current cloud function supports, let's say you want to run a piece of code, but the maximum timeout allowed in the current generation cloud function is 9 minutes only. But with the new generation, it supports up to 60 minutes. So basically you can run longer data processing pipelines, and those kind of use cases can be covered using the new gen. And also even the memory, currently by default, you will get 256 MB when you deploy a function, but you can go up till maximum 2 GB. But now with the new generation, you can go even up to 16 GB and 4 vCPUs are available. Early in the current generation, you cannot decide on the CPUs, but in the new generation, you can do that actually. And this is about the event sourcing, that now it's almost kind of 90 plus event sources are supported. And also one another thing regarding the new generation of Cloud Function is that earlier version of Cloud Function used to be like kind of a single threaded. So when you get concurrent request, like let's say you have an HTTP Cloud Function, then you get a concurrent request of 100 requests, it will spin up 100 instances because it's single threaded. But right now in the new gen, it can serve up to 1000 concurrent request in one instance by spinning up different threads. So that's how the new version of the Cloud Function is being designed. Okay, so I'm going to the fourth topic, which is basically the data management, which is nothing but the databases and then the structured and the unstructured data. So how do you store the data using Firebase? So Firebase has got two offerings in terms of database. One is called the Cloud Firestore, and the next one is Firebase Realtime Database. So Firestore is the next generation from the real-time database. So it's purpose built for app development. So before getting into the details, I just want to bring up the topic of what are the managed database offerings from Google Cloud. When you say managed database offering, this is actually a keyword used by all the cloud providers. You don't need to manage any of the infrastructure. Let's say you have to run a database today in your local laptop or on a VM. You will have to spin up a VM, you would install it, and then you need to allocate that much of CPUs and memory, everything. So that part is completely handled by, it's a pre-installed database, I would say, and provided by the cloud provider, and you just need to bother about the data in the database. So these are the managed database offerings from Google Cloud. When it comes to the relational and non-relational, this Cloud Firestore, what we are going to discuss is a non-relational database, which is basically a serverless, scalable, document-based database. I'm not going into the details of the other database in the interest of time. So a typical mobile app development, how it used to be in a traditional way. I mean, not really traditional way. Currently also, a lot of people, when they start thinking about an app development, they have to think about the database, whether it could be a relational or a non-relational database, then API server, because you cannot expose a database directly to an app. I mean, like a user, because you need to come through API layer to have its own protection, because the traditional databases, they don't give any kind of extra layer of security. When the user directly comes and do something, you screw up your database. So then the authentication service, protecting the API server. So then we need, I mean, in the new age apps, you need all this local storage for the apps to work offline. And then you need the synchronization logic, because when a user updates something, all the other users who are connected to those apps, you need to have that synchronization and then caching everything. So in a traditional approach, the developer has to manage everything. You need to go and find out third-party libraries. You need to build your APIs, everything for building a mobile app. So the equivalent amount of time what you invest in building an app, the same amount of time you need to research on these kind of non-functional requirements also. So what is Firestore trying to solve here? So basically Firestore is built to tackle the above common problems in the previous slide. Basically, the Firebase Sdk is fully Firebase is having an Sdk, and that Sdk supports a lot of Firestore based, Firestore functions, and that includes functions for iOS, Android, and web native. So the whole core idea is here is that you get rid of a middle tier. Like I mentioned in the previous slide, the API server, your apps can directly access the database. So which is actually, in a general terminology, it brings in a lot of challenges, and then it's quite unusual, an app directly connecting to a database. It always comes through an API layer and then with an authentication and authorization. But in the Firestore world, you can directly connect to the database. You can still go via an API server. There is no harm in that. But if you want to bring one layer down, we can still do that, because Firebase, if you here you club the functionality of the Firebase authentication, and in the Firestore you have something called security rules. So you club the Firebase authentication and security rules to bring in a more powerful kind of a access control to the database, which we will cover in the next slide. So, and then what all are the other features what Firestore is trying to solve is basically it brings in inbuilt synchronization, offline mode, everything. Then we talked about security and data validation using the security rules, which we will cover in the next slides. And also Firestore, it's quite easy to integrate if you want to bring in functions, additional functions like a business rule before writing a data into a Firestore, because here now the app is directly talking to the Firestore. So before writing that data into the Firestore, let's say you want to do some business logic, like, okay, you have to send a mail to someone and then go for an approval, not an approval, like something like that. You can actually bring in that cloud function to write that business logic. And then based on that cloud function, you can run that logic and then the data will be saved into the database. So that way, the integration part is also quite easy. So it's a time check. Okay, 7:12. Mikael, do we have time? I mean, another 5-10 minutes to cover this?
Yeah, go for it.
Okay. So getting into the little more details of the Firestore, the data model. I mean, this is, like I mentioned, it's a NoSQL database. So NoSQL document-oriented database. So you might have heard about the concept of RDBMS. So unlike the RDBMS, there is no concept of table and rows here. So every record, for example, let's say take an example of an employee or a user object. Let's take an example of employee object. So employee will have its own first name, last name, day, age, everything. So in a traditional RDBMS world, you will save one record as a row. Here, the concept is like every record is a document, and documents are organized into a collection. So if you look at this kind of a diagram, so you can imagine like this collection is basically kind of a folder. It's a container of all documents. So this is employee 1, employee 2, employee 3, and each document will have its own set of data. When you say data, it's basically a key value pair. Like here, we have organized the data like, okay, my first name, this is the key, and the value is Adda, born in 1815, something like this. So this data can be organized in multiple ways. So here it was like a kind of a plain structure. It's like key value, but here it is kind of a map. So we define name as a key, and then it's a map structure. So in that map, we have again first and last as again values inside that. So it's like we can organize data in the document in the way we want. So this is the overall data model. So if you go to the a little more detail into the document structure, so like I mentioned, document is the unit of storage in Firestore, and the data type, like here we saw the data type here is string, and here if you see born in 1815, it's a number. So the data type supported by Firestore is like all the required data types are supported, like a Boolean, number, string. Then we have geopoint for storing latitude, longitude. Then we have timestamps for storing date and time, and then arrays and maps. So if you think in a MongoDB perspective, if you have used MongoDB, you can consider a document as a very lightweight JSON object. So that's how it is. I mean, even in the next section, we will see something called real-time database. So real-time database purely works on a JSON model. So this Firestore is kind of a next generation of the real-time database. So the concept is almost similar, but they are here they have organized it into a little more structured way, like a collection and then document. The main reason is because it will be more, the queries will be more powerful. You can query the documents inside this Firestore in a more powerful way. So I will during the demo part, we will show how do we fetch data from this, because it's something similar like what we used to write it in the SQL days. We have something called Firestore query language. So we can basically query it using the Firestore SDK, and it is much powerful actually compared to the other document-based databases from other cloud providers. I have personally worked on other cloud providers, NoSQL DB, but compared to that, Firestore querying capacity is really good and the performance wise. And there is one restriction what they have kept, because to improve the query performance only, we mentioned about documents, which is basically the unit of storage, but you cannot store more than 1 MB of data on a particular document. So let's say you have an employee record, and employee record, you are going to store fields like first name, last name, age, then date of joining, etc., etc., etc. So if you store more than 1 MB, then it will not allow. There are multiple reasons for that. One is mainly for the performance thing. So when you query documents, if it is too huge, they have to create too many indexes. I will come to the index topic in the next slide. So if you want to store more records on particular document itself, there is a concept called sub-collection. You will have to overflow the data in the document into a sub-collection of that document, which also I will show you in a moment. So sub-collection is nothing but a collection itself, but a collection within a document. So you can actually build a hierarchical model like this. So this is the concept of sub-collection. Let's say this is the GUI or the web console of Cloud Firestore. So let's say you have a employees collection. So this is what the collection, when you create an employees collection, it will look like this. And then you can add n number of documents, which means that each document corresponds to one each employee. Here I have only one document. I can add n number of documents under this employees collection. So these are the attributes of that employee. And let's say I need to store the attendance records of that employee. So if I start storing that attendance record of every day of that employee, like 365 days, it will be then the document will not hold that much because it will cross 1 MB. And also it's kind of a growing document, growing record. So then what we will do is that we can structure the data model in such a way that each document, each employee can have its own sub-collection, something like attendance record. And under attendance record, each day I can add it as a individual document. So let's say I have individual document for 22nd February, I checked in at 8 AM and then checked out at 17. Then the next record will be for 23rd February. I checked in at 9 AM, let's say. And then, so if you want to build an attendance record for this employee, I can query for this employee and then come back and get the attendance records for this particular month or this particular year. So that is how you need to model the data in Firestore. This is the overall concept of documents and collections. So this, when you say sub-collection, it is basically a collection itself, but it is living inside a document. But if you see these employees, you don't have any parent document for that. This is the root collection basically. Then one more topic I need to cover is basically the security rules. Security rules are nothing but, earlier we discussed how we bring in authentication plus security rules so that you will get a more tighter role-based access system. So earlier we have only authentication, who is the user, but that user, what is he supposed to do? So that is what the security rule is trying to bring in here. Okay, I am having an identity, what all documents in that collection I can access. So the security rules is the syntax of security rules, how we write in Firestore is like this. So every security rule starts with a match statement. And here, if you see the third or fourth line, here we have written document equal to star star. This is a wildcard. So this rule, example one rule, which says that, okay, if you want to read any of the document in that Firestore my Firestore database, you need to be having a valid authentication. No, none of the public can come and directly write anything into any of the document. on the other hand, if you see this allow read, it doesn't need a if condition. It doesn't have an if condition. So anyone in the world who is having access to my app can come, and you don't need to log into that app, but just you are giving a, let's say, a dashboard without a login. You can read any of this document, any of the document. Like when I say document, like let's say you have employees and assume that you have 100 documents here. You can completely come and read without logging in. So that is what this security rule says. But this is so flexible. In this, the second example, I say that, okay, match. Instead of a wildcard, I say that, okay, I have a cities collection. Instead of employees, I have a cities collection. And any of the document, this curly braces city means that each city document inside the cities collection. If I have to read cities collection, I have allow read, then maybe I don't have an if condition, then allow write. I would say that, okay, if request dot auth not equal to null, then only you can do some kind of writes. So I just want to show the syntax. Instead of document equal to star star, you give like, okay, you match a particular pattern, then only for those collection you need authenticated user. For the other collection and other document, you don't need authentication. Maybe you can define other rules. So that is what the concept of security rules. So I have no slides related to the indexing part, but I just want to bring one line to that. I mentioned about the document size, the 1 MB limit, and one main reason is because of the concept called indexing. So indexing concept is way, I mean, like from the RDBMS world, it's the same concept. Basically, it's a important factor for the performance of the database. So it can be easily related to a books index, basically. So you have a index page which will mark to a page number. Similarly, DB is having that same concept. So in Firestore, how they do the indexing is like, there is a concept called single field index and a composite index. So if you take the example of employees, excuse me, if you create this employees document, each field, age, first name, last name, every field will be automatically indexed by Firestore. That's the beauty of Firestore indexing feature. So that's the reason why they're keeping a limit of 1 MB, because they cannot build the index like so big, then the index's performance will be bad. So every query, when it runs, it knows that, okay, there is an index for each of this field, and then it will go and refer that. Then what is a composite index? Composite index is nothing but if let's say your app, it may not be a usual scenario, but your app can be querying all the employees with, okay, let's say, bring me all the employees with the first name equal to John and age less than or equal to 30. So it's like it has to query two different fields. So then Firestore cannot automatically build that composite index, because let's say you have 20 fields and Firestore cannot create index for all the permutations and combination of the columns or the fields. So for those things, it will ask you to create composite index manually. So let's say you have fired a query like what I mentioned earlier, and that composite index is not available. Then the query's response will be, sorry, that index is not available. But the good part is that Firestore will return you a big URL, which is basically a HTTP request, a REST API request to build that composite index. So you just need to fire that URL, and then that composite index will build in against your database. So it's that easy to bring in a composite index. Hope that single and composite index without a slide, you understood the concept. So that's it. And next is the real-time database. I will hand over to Mikael, and
yeah, thank you. Yeah, so basically what Sijohn said, I mean, at least now in the end, regarding Firestore. So Firestore is really, I mean, useful, really advanced. And this is actually a next-gen database in that sense from Realtime database. So Realtime database is actually Firebase's original database, if you want to say it like that. Yeah, so Firestore is more of a complex, more complex solution built on top of Realtime database. So a lot of this will be sort of repetition. I will go through some of this real quick because it's sort of the same information. But yes, so basically the big difference right away between Firestore and Realtime database is that real-time database is using an actual JSON structured data for all this data that it's storing. But except from that, it's actually storing it in a similar way. So it's a NoSQL database just as Firestore, but it's storing it in a JSON structured format instead of in documents. Other features that are very similar or the same as in Firestore is, for example, data synchronization to connected clients, and what's it called? The data availability during outages. So, for example, if the app goes offline, then the user will still have access to the data, and this is mainly because the data is actually stored on the disk itself. So it will be able to actually access this even though the app is offline. And right away when the app comes online again, it will automatically synchronize this data, so it keeps it up to date it will keep it synchronized to the actual state of the database. And just as with Firestore, this also functions without an actual backend layer. So you can connect to real-time database just as you can to Firestore. And of course, for this, you use security rules instead of, or for the actual authentication layer. You can go to the next slide. So this is actually the big thing between the real-time database and Firestore. We have a few different, we have a few comparisons that we can do between them. Of course, they are very similar, but the key differentiators are, of course, the Firestore builds on the successor of the real-time database, but it uses a new and more intuitive data model, which you saw with the collections and the documents that Sijohn talked about. And also what he mentioned is that Firestore also uses richer and faster queries, and also it scales much further than the real-time database does. So that is basically the whole core of Firestore is basically more advanced than the real-time database. So for a lot of use cases, Firestore is just purely better than real-time database, but real-time database, of course, has its a few benefits to it. But one more limitation regarding queries is the real-time database has some limitation in regards to how you can do, for example, sorting and filtering cannot be done on the same time or in the same query. You can do both, but not at the same time. And also queries can be quite slow for real-time database when you have a lot of data, because everything is stored in one JSON structured tree. So when the data gets quite big, it can impact the queries quite a lot. One thing that real-time database has that Firestore does not have is native presence support. So basically what real-time database can do is that it can keep track of all the client's connections. So it knows if a client's connection is actually online or offline, which Firestore does not support natively. This can though be worked around if wanted by using the presence support in real-time database. Then you can simply create a cloud function to actually synchronize this data to Firestore and keep the same functionality that way. But Firestore does not actually support the presence support natively. And that is something that real-time database supports and has like an edge on top of Firestore. One thing that is also quite a big limitation, I'd say, to real-time database is that it's only available in very limited locations. So it's available in regional configurations, and the databases are actually limited to zones inside these regions. And I think it's only like 3 different zones or something like that, so it's very limited. I'm just gonna check quick. Okay, so before we go to the next slide, the one thing I'd say that real-time database has on top of Firestore, except from the presence support, is if you have small amounts of data, but you do a lot of queries, then from a pricing perspective, real-time database can actually be quite a big win, because it has a different pricing model than from Firestore. So Firestore actually has pricing based on both stores, but mainly on the request that you send, which real-time database does not have. It only has it, I think it's on the storage, and I don't remember exactly what it is, but it's mainly on the storage. But the big win is actually if you have small amounts of data and a big amounts of queries, then real-time database is actually better from a pricing perspective. But then, of course, it's limited in other aspects, so you need to take those into consideration as well. Yes, next slide. Yes, so this is just a small comparison between the two different structures of data between real-time database and Firestore. So as you can see on the left side, we have real-time database, which is purely just a JSON structured tree. This can be really complex if you have a lot of data, this can be really complex to follow. But as you can see from Sijohn's example, with using Firestore, you have the collections and documents, and it's really easy to actually structure this in a good way to actually view it from the console, I'd say. And then, of course, from a programmatic point of view, it may be different, but to just look at the data, it's much easier in Firestore if you have a lot of data. Yes, you can go to the next slide. Yes, so if we go into go away from the actual databases and go more into blob storage, we have cloud storage. So cloud storage is actually, the backend is a Google service. So basically, as written here, under the hood, we use Google Cloud Storage, which is a Google service to store files, which is basically videos, images, text files, all those kinds of files. It's just a blob storage. So cloud storage for Firebase is basically just an addition on top of Google Cloud Storage to be able to use the Firebase Sdk and integrate with Google Cloud Storage, or with Cloud Storage in this case. And this, of course, helps with mainly the authentication part. So you can use Firebase Authentication to authenticate to cloud storage instead of going the Google route. And except from this, cloud storage supports a few different features that are really useful, which is, for example, object versioning and lifecycle rules. So object versioning is simply just keeping different versions of the same file. So if you upload a new version of a file or deleting the file, it will make the file non-current, so it will basically not be live. So you can see that it's being unlisted, but they will not be deleted unless you specify the generation number of that specific version, which is basically an automated generated number. But with lifecycle rules, you can do this in an automatic way. So lifecycle rules are basically a way of specifying rules on a bucket to automatically, for example, remove objects if they are older than a specific date, or if you have a set amount of versions, you can delete them. So, I mean, let's say you have 3, or it will only keep the latest 3 versions. So if whenever you get the 4th version, it will delete the first one. So that is what lifecycle rules are. It's basically a way of automatically delete or move files depending on a specific thing that happens. Sort of the other way, or the opposite of lifecycle rules, is the retention policy. So retention policy is a way of forcing objects to not be deleted. So you're able to basically specify that this specific in this bucket, all the objects that are put in here cannot be deleted for, let's say, 60 days. So even if you go in and try to delete the file, it's not possible because you have this retention policy. You are also able to actually lock this retention policy if you want to, using a retention policy lock. So basically what this will do is that it will force your retention policy to stay on the bucket, and you are not able to unlock this as long as you have objects in the bucket that are under this retention policy. So let's say you have a retention policy that no files can be deleted in 60 days. If you have 3 files that have been created in the last couple of days, and also you have this retention policy lock that on that policy, if you have a couple of files in there that has been recently created, you're not able to unlock this policy to be able to remove the policy to actually delete the files before these files that you recently created are older than 60 days. So they are outside of this retention policy. So as long as the policy is like activated on an actual object, you're not able to unlock the policy lock. So that is something to keep in mind. So it's basically just trying to make it as secure as possible, so you're not able to remove files that should not be removed. That's basically what it is. You can move to the next slide. So for cloud storage, you can also use security rules. Or actually, one thing I forgot to mention on the last slide, you don't have to go back, but to use the lifecycle rules and the retention policy, you actually have to go the Google route. So you either go to the Google Console or use the terminal, because those features are not actually available in the Firebase Console. Just something to keep in mind. So it will not, I think, be possible by using the free plan in Firebase, for example. You need to use the Blaze plan and connect to GCP. But yes, so security rules are also available for cloud storage. And this works just the same way as it does for Firestore and for the real-time database, for example. This example that I've written here is basically limiting the upload size of the files that you upload to cloud store or to cloud storage. And so this specific rule restricts all files that are bigger than 5 megabytes to be uploaded. So it only allows smaller files to be uploaded to this specific bucket. But yes, we don't need to go deeper into that. You can go to the next slide. What can be just interesting to note as well, for the security rules, you actually have a monitoring section for these. So you're able to see basically the invocations, if they are allowed, denied, or if there are any errors. Of course, this is very narrow. So if you, very like an overview picture. So if you want to see more in depth, you have to go to cloud monitoring, which is also in GCP. But then you will be able to get a much better overview of what kind of invocations that actually happen, and if you have any other specific things you need to see. But it's good to at least know that there is a monitoring section for these rules. And the next slide. Yes, so a similar thing also exists for the usage of the storage itself. So here we have a few billable metrics. As I said, if you want to see specific things, you need to go to cloud monitoring. But this is just a good picture or a good view of viewing the billable metrics. So here, for example, you can see the object count, the total amount of requests, these things that are billable. If you would follow the link in the bottom right corner, you would actually be able to see, because you have a free tier that you are able to use this amount or store this amount of data, for example, before it actually costs something. You can see that kind of information using that link. So you will see, for example, that you have used, let's say, 30% of your free tier for a specific thing. which is very good to use if you are on the Blaze plan, for example, and don't want to pay too much. So that is just a good thing to keep in mind as well. But it can be found from other places, but it's in Firebase. Yes, so that is about cloud storage. The last thing is regarding machine learning. So this is more when you look at the future. So Firebase has its own offering for machine learning. So basically, you can deploy your own TensorFlow Lite models, which is the type of models that Firebase uses for its machine learning offering. And Firebase will take care of all the hosting and serving it to your application in a dynamic fashion. So this means that you basically are able to constantly update these models without having to update your application at all. So you can, let's say you deploy your application today with a model that you created yesterday. You can continuously update this machine learning model like once a week, for example, without having to touch the application at all. Because as long as it's hosted and served by Firebase, it will dynamically update in your application as well. So custom models can be automatically trained with the help of Cloud Auto ML Vision Edge. So you basically just upload your own images and labels, and they will be used to train image and object labeling. So these are used for recognizing concepts in images. So basically, an image labeling model is where a label is assigned to the image itself, and an object labeling model is where the labels are assigned to regions of the image, meaning that multiple objects can be identified within the same picture. So there are two different ways of seeing it. So either you have the image labeling model, which puts one label on the whole image, or you use the object labeling model, which assigns labels to regions of the image, which is basically objects in the image. So it's two different ways of using those models. Cloud Vision APIs is also an API provided by Firebase ML. So with that, you're able to use pre-built models that can be used for example, text recognition, image labeling, and landmark recognition. So these models only cover images as sources, except for text recognition, of course, that also has the possibility of using documents as source. But if this doesn't fit your needs, but you're not able to create your own models, then you can create your own models and take advantage of using the ML kit. So ML kit is basically, as stated here, it's actually a standalone SDK that is used on device instead of in the cloud. So I will actually cover that a little bit in one of the coming slides, which are two different types of models. But you're able to use pre-built models with the help of Google's machine learning expertise. And these models cover areas such as barcode scanning, face detection, and there are also others such as post detection, object detection, tracking, and other things. But yeah, so Firebase machine learning covers a bunch of different aspects of machine learning in Firebase, both on the device itself and in the cloud, but I will cover these. Yes, you can go to the next slide. So as I mentioned, there are two different ways of using these models. So there's actually one type that is a cloud-based model, and then there's one that is on device. So the cloud-based model is basically where you do all the the processing, etc., in the cloud itself. So this is good for getting accurate results, because you have a lot more resources in the background actually doing the processing. The problem with using a cloud-based model is that you cannot do real time, because you always have the latency of sending the request and the data via the network. So you will always have the extra additional latency from the network traffic. So that is a really good part of using on-device models, which is provided in the ML kit. So on-device models is basically the other way around of doing it, which is basically doing the processing on the device itself. So this is good mainly for having faster results, which is really good for real time. So you can do, for example, video processing using a on-device model, but that is not possible doing it using a cloud-based model, because you have this delay. So you will not have it in real time in a smooth picture, for example. Which is also good, for example, is that you have no external communication for processing, because you do everything on the device itself. And you can also do processing on sensitive data that you do not want to leave the device itself. So if you have sensitive data on your device and you do not want to, for example, send that to GCP, but you still want to do processing and machine learning on that data, you can use an on-device model to use the processing on the device itself and still have the same functionality. Like the only benefit of going to the cloud is more or less accurate results. That's like the big differentiator in this case. Also, one thing to mention for on-device models, models can become quite large depending on how you use them in the end. And of course, for on-device models, this could be an issue because devices have limited resources, and you do not have limited resources in the same sense in the cloud. So that's why you also use light models for these on-device models, because they should be as small as possible. Yes, you can go to the next slide. So basically, I just also listed a few more because machine learning is quite a broad topic. So if you want to look more into that, I've listed a few of these here, and we'll try to make this available to you afterwards as well. But here you can read up on more or less all the different aspects of Firebase machine learning, using TensorFlow light models and auto vision, for example, and those kind of things. But I think that's about everything for the theoretical parts. You can go to the next slide. Yes. So if you have any questions that you have not asked yet, feel free to do that now before we go into the practical part, which is first of all a demo, and then you will be able to actually do the practical parts on your own as well. So do we have any questions first of all? No? I mean, so as I said, feel free to just stop at any time to, even during the demo or during the interactive parts afterwards, if you have any questions. But yes, Sijohn, feel free to do the demo.
Yeah, sure. Thanks, Mikael, for the session. So we will quickly, I think we have time till 8 only, right? We have 10 minutes, so I will do a quick walkthrough. So the instructions for this demo, I mean, like whatever we are doing in this demo, the same instruction set to pull that code base and then, excuse me, and run it locally and then deploy it to a Firebase. The whole instruction will be available in this Git repo. There is a README there. And you can actually try it out by logging into console.firebase and use the Spark plan. So without wasting much time, I'll move to the demo part. So before going to the demo part, this is the Firebase console. So like I said, console.firebase.google.com. Once you sign up, you will be asked to create a new project. And in my case, this is the name of the project. And then this is the dashboard. So these are in the left side, if you see, these are my section, what we covered today: authentication, Firestore database, real-time DB, storage, hosting, functions. So first is authentication. So this is where you enable authentication, and these are the various sign-in providers what we have. It's available right now. We are basically using the email password. So you can create a sign-up page. So rather, I mean, instead of that, for the easiness of the app development, we are using an add user mechanism through this console itself. Like you can just create an email and a password, and that's it. I mean, that user is created. So we will be using this authentication, this user, which is demo@snp.io in our demo app. So similarly, if you go, I mean, if you have to enable sign-in methods like Google or Facebook or anything, you can actually add a new provider here. So you will be able to get Google, Facebook, everything. So then you can provide that kind of sign-up mechanism. So going to the Firestore DB. So this is the same screenshot I was showing in the slide deck. So I'm not going into the details of that. You have the data tab. Then here is the place where you define the rules. So this is where was another screenshot. Then this is the indexes. Here we have not created any composite index because I mentioned it is, you have to manually create it, but the single field indexes are automatically created. You don't need to bother about it. So I'm not going to the real-time database or storage or anything. I'll just show hosting and then we'll move on to the app. So this is the hosting dashboard. So here you can get a usage dashboard, which says how many MB of data we downloaded or how much data size. And then if you go to the dashboard, how many times we have deployed. If you see this section, I have deployed it today once at 10:39. And then if you want to roll back, and remember, all these things can be done through the Firebase CLI as well as through a REST API command. So for the sake of easiness, we are doing it through the console, but in a real world, maybe we will be using a automation mechanism using command line to do this deploy and roll back everything. So this easy it is to roll back from the console. And this is the automatic subdomain, which I mentioned. So if you look at my project name, Sijohn-playground-pet Devoteam. So you automatically, once you deploy it, you get a subdomain called devoteam.web.app and a firebase-app.com. So you can add custom domain, like let's say you have bought something like example.com or acme.com, and then you simply come here and add that, and then you have to verify the ownership by providing the details what Firebase has given you. For example, then Firebase will generate the DNS records, what needs to be provided, the text record. This is the verification code. Actually, you have to go and place it in your DNS provider, and then you are live. So it's that easy. And that's it. I mean, I'll not go into the function because your console will not have function, because if you're using the Spark plan, here I'm using a Blaze plan. That's the reason why that functions are there. So here we are going to demo a small app. So that app is called a Salt and Pep. It's a fictitious restaurant menu app. So here you are seeing a list of items from that restaurant. So this data is coming from Firestore database, and you have a login screen here. So once you log in, you will get into the dashboard. And the dashboard is for basically for the admin to add new menu item. It's just a simple app to demonstrate the features. So if you look at the Firestore database, you have something called menu items. So all these data what you're seeing here, the spaghetti bolognese or like Coca-Cola or smoked chicken wings, these all are like individual documents from the menu items collection, and we are fetching this data in our web app. And there is another collection called menu categories. This is something like, as an admin, when you add a new item, I want to populate this drop down with a predefined, so that users don't make any kind of mistakes by typing in. So these are the drink starters main course. This is a pre-populated list. So for bringing in that data, I have just added this menu categories. 4 documents are there, meaning like corresponding to each document, we have a category name, cat name, and a cat number. That cat number is just for ordering purpose. And we mentioned drinks, starters, etc., like that. So how is this structured in a code? So I'm not going to the details of the code because the original intent of this session is to demonstrate the Firebase hosting authentication and how to consume the data from Firestore rather than going into the details of how to build a web application. So it's a typical React-based app we have built here. So when you can pull this, the whole salt and pepper code base from GitHub repo, the link is provided in the slides. So when you pull it, you have a relatively a bigger README. You can go through the steps to set it up. The key things what you need to do is there is a file called firestore.js under the utils. So this is the key actually, your project details. I mean, when you sign up and then you create a Firebase project, and then you will be getting a API key and a project ID, everything. So this is, you go into the project overview, or even much before that, when you create a new app, you will be getting all these details. But later on, if you want to get it, you can get it from here. So this is the details corresponding to my account, but you will be getting a different set of API key and things like that. So you just need to come and change all these XXX when you run the application. And then the other key file is basically the Firestore Services.js. This is where I'm pulling all the details, or when you are adding a new menu, updating a new menu, deleting a new menu, and also fetching all the data. This is where the Firestore Firebase Sdk come into play. So we get a DB handle, which is basically the database handle. Then this database handle, this SDK is powerful enough to query all the records. Like, let's say you have a collection called menu items or menu categories. So how do you get all the details of the menu categories? Like db.collection menu categories .get. Here .get means blindly get all the documents, like let's say all the records under that menu category collection. So here is a place where we bring in, inside the get, we bring in the where conditions. Let's say if you want to get menu category where category cat name equal to drinks, you will be giving the where clause inside the get. So that is how the SDK is structured. And this is a promise. Basically, it's an asynchronous operation in the TypeScript, JavaScript world. And then you get all the categories, and then it is being passed to the page which is requiring that. So this is how easy it is to fetch all the records. This is similarly, you have add, update, and delete functions to do the necessary action. Similarly, in the login, we have a simple login menu and login page where we use the Firebase auth.sign in with email password. And then it accepts the credentials from we have not created a sign up page. So that's the reason why I told, like, we will go to the Firebase console itself to create the user record for the interest of the time and make the app simple. You can, as an exercise, you can create a sign up page and then use the Firebase SDK itself, the auth SDK, to bring in the sign up functionality as well. I think these are the key things. I am not going to the dashboard and the menu and things like that. So like I mentioned, how easy it is, or like, let me go into my the Git page. So this is the repo, and all the details what needs to do to run this project. And also to sign up for a Firebase project, everything is mentioned in the README. If you have any questions, feel free to come back. But I think today we don't have much time for you to run it. And also you can run this app locally as well. The 3 key things are basically, you need to install Firebase CLI. So installing Firebase CLI is super simple. It's a npm command. And then you need to init first you develop the React project. So when you pull it, then you need to do a Firebase init. And after the Firebase init, you need to log into the Firebase through the command line and then basically run the Firebase deploy. So I'll just show you from my terminal. So this is my project. So Firebase, I'm not going to do an init because I already init the Firebase. So that's the reason why I have this Firebase RC and Firebase.json here. So if I do a Firebase login, I can see that I'm already logged in as sijohn.mathew@devoteam.com. If I'm not logged in, it will take you to a web page. There you will have to key in your credentials and then it will take you back to this terminal. So now I need to do the build. So npm run script build. I'm not going to build it because it's already built. So the next command is basically Firebase deploy. So it knows to which account I need to deploy because it's already logged in, and it is super simple. It is now live and anyone can, it's live across the world. So it is available to any user across the world. So it's that super simple. If I go here and if I go to my console, I can see that my hosting is just now updated at 2001. If I have to roll back to the previous one, it's that easy. So this is pretty much about the demo part. So definitely we would recommend you to pull this code from the Git and just play around with the steps. Then you will get a handle of how easy it is to set up a web app and use the auth engine, use the Firestore DB, and then how to deploy it. And then you can enhance the features, and then you will learn how to do more things using the Firestore queries. And also maybe you can bring in Firebase ML functions into the app. But I think I'm not sure, Mikael, like with the Firebase Spark plan, is it possible to use ML?
I'm not actually sure. I have not taken a look. I can take a quick look, but I'm not actually sure.
Yes, so that is about the demo part. If you have any questions, feel free.
Yeah, I have some questions. Like, okay, first, thanks for your presentation. It's really good. And I want to know, is there any like the role management for the authentication? Like, can we have some admin accounts and maintainer accounts so we can have different permissions for different type of accounts?
Mikael, you want to take that question, or shall I?
I'm looking at the plan.
Okay, yeah. So like I mentioned earlier, the Firebase authentication engine is purely for authentication purpose. So the concept you asked is basically for the authorization. What am I supposed to do as an admin or as a coordinator? So if your policies, I mean, like if you are a user, for example, I am a user Sijohn, and I am having only limited set of rules saying that, okay, I am tagged as an admin, I am tagged as a coordinator. There is a concept called in the Firebase authentication itself, but unfortunately in the web console, this is not available. There is a concept called custom claims. So basically to the user object, you are plugging in something called, okay, a role. It's kind of a key value pair itself, custom claims, role, admin. And then you interpret that user object in your app. And then once you log in, that user, we can, in that JSON web token, you will get that, okay, custom claim role equal to admin. Okay, then you can make that user to perform that kind of operations. That is basically one way of doing it in the app itself. But here, if you're talking only about controlling the data from purely from a role perspective, I mean, not on the app side, but on a database side, if you want to purely control, what you can do is that you can club the security rules, because here in this request.auth, this is basically you are getting the control of the user who is currently logged into your app, and you will get that request object along with that user's credential into the database. So here you can define that, okay, this user is not supposed to go into this collections, this document, and then you are not allowed to read and write into this. If you want to restrict on only on a DB level, you can do it in the security rules. But if you want to do it in an app level, you can use custom claims. But like I said, if your rules are too complex, like you are an admin, then a coordinator, but you want to have some other things, if you are having this kind of combinations, then you will have to build a custom role-based access control by putting the details into the database itself. In the database, you will create a collection called rules engine, and then you say that, okay, user one, do this kind of things. I mean, these are the various possibilities of doing it.
Yeah. Okay. Thank you. And yeah, I also have some other questions. Like, for example, if we already have some applications with the relational database, maybe MySQL or PostgreSQL, it is possible to transfer the data from this kind of relational database to Firestore.
It's a tricky thing because there is no, I mean, none of the NoSQL or this kind of document-based models support that kind of, because you cannot do a direct one-to-one mapping. So you will have to write your own script to bring in.
Okay.
Yeah, but I don't know, Mikael, are you aware of any kind of tools like that in the market?
Not that I'm aware of. Not for Firestore real-time database. I don't think so.
Mm. Yeah.
So I think something custom has to be built for that.
Yeah.
Just to add real quick on the machine learning stuff, it is possible to use custom models for if you have the Spark plan. So if you don't want to supply your credit card, it is possible to use custom models, but it's not possible to use the Cloud Vision APIs.
Yeah. And okay, last question. Too many questions. Like, I feel like currently the Firebase is mainly used for like web applications or mobile applications. And can we use it for maybe desktop applications in the future or maybe right now?
But when you say desktop application, can you tell one use case? I mean, like it can be still, I mean, I don't see Firebase being used for a desktop-based application because maybe you can use the database component for communicating to from the client to the server part. But other than that, I don't think hosting is needed in that case. It's not necessary, but still you can use the authentication piece and database piece for your client to communicate to the server. But yeah.
Thank you. Yes. Anyone have questions?
I have a question. It's about in your demo, you showed how to create a user and creator and delete. And I want to know how to use the function to write some query to search in this database, from this database.
Okay. So that's where I was telling about this. Your question is around how to query, let's say, so let's say you have a collection called menu items, and I want to know what all are the items, categories available in my collection with a category as main course. So I mean, I'm showing it through the console here. The same thing can be achieved through query. So this is how you filter out in the console. So I am adding a condition item category equal to main course. So if I can see that there are 4 menu items which are tagged as main course. So out of 7, I got 4 results. So if you look at that, this is how the query is being generated by the collection, by the Firestore query engine. So DB, I mean, in the code, if you see, it's called db.collection, and we provide the collection name menu items. Instead of .get, So in the query, you could, in the code, you would have seen that .get. Instead of .get, where you pull all the records, all the documents from the collection, here we give where item category equal to main course. So that way, the query knows that, okay, I need to pull out only those records with main course as the category. So this is how it is, the query is getting structured. If you want to query for specific things, or if you want to query everything, do a .get. Hope that I answered your question, or was your question something different?
Yeah. So you mean, so you type this, just copy this query in this VS code.
Yeah, either you copy it.
Okay.
I mean, that was for an easy visualization. I showed it there. But once you start using the SDK, you don't need to go there and then find it out. You will automatically, I mean, like with the type ahead feature of this VS Code or whatever coding editor you're using, you will be easily able to generate the code, or you have the SDK reference materials to see how to write the collection. I mean, how to write the queries. And also these queries are a lot more powerful when it comes to arrays, and there is a concept called collection group, which I'm not getting into it. So when you need to write complex queries, you can refer always the Firestore documentation, and there are quite a lot of interesting query features you can use. Even you can use .sort to get a sorting, .filter, and whatnot. I mean, like bring only first 10 results from the query. Those kind of things also you can refer. You can go to the Firestore documentation to get all the details about how to query it for more fine-grained control.
Thank you.
Okay.
Do we have any more questions?
Yeah.
No? Yes. Yes, we can do that. We can add the slides, so that will be available. But yes, I think we can stop the recording. And then if you want to do the interactive parts, feel free to do that. I mean, you can reach us